Okay, exercise 14G, arrangement in a circle. So we're going to start with arrangement in a circle and why this is different when you arrange the object in the lines. Alright, so firstly just start with, say for example, if we have four letters, A, B, C, and D. Now if we talk about just a line arrangement, okay, where these four letters is just rearranging the lines. We've done this before. We can have like A B C D, A B D C, and then continue forever. So in this case, we're gonna have 4 factorial ways to rearrange them. Okay, and that is equal to 4 times by 3 times by 2 times by 1. That is 24 different arrangements if you want to rearrange these A B C D 4 letters in a line. Now, how about, if we want to rearrange these 4 letters around the circle, okay? Like, for example, if they're sitting in a dinner table around a, circle here, and how do we make, how many different arrangements are possible? Okay, so let's just have a look at the circles here. So, for example, we've got a circle, and we're going to rearrange them, all right? So, like, for example, circle arrangement. Alright, so we can have A, B, C, and D. Now, if you look at these circle arrangements here, alright, that's one arrangement to A, B, C, D. Now, the difference between circle arrangement and line arrangement is if we have another circle, for example, and then if I place the A here, B, C, and D. Now, if you just look at these two arrangements, they are literally the same arrangements here. Alright, because if you try to rotate this circle around, alright, this way, anti-clockwise direction, then you will have A in the same place. Or basically what happened is, from the first circle arrangement to the second circle arrangement, all I did is just rotate the circle 90 degrees clockwise, so where the A is here. Now we can continue this process here by creating another 2 circles. I think I should make the circle like the same size. Alright, another 2 circles where you can have you can rotate the circle in clockwise direction by another 90 degrees, where A is here, B is here, C and D. Okay, and then we can have A, B, C, and D. Alright, so if you look at these 4 arrangements here, they're considered to be the same arrangement. This A, B, C, D, no matter how you rearrange on the circle right now, this A, B, C, D is still in the correct arrangement. However, if you look at the line arrangement, imagine, for example, if I just break the circle at this point every time, okay, break the circle at this point, then the arrangement for this circle is just A, B, C, D. And imagine if I break it here, the arrangement is D, A, B, C, and this is C, D, A, B. And the last one is B, C, D, A. Because what I'm doing here is if I break it here, I'm just going to start from this, which is the first letter, and going around the circle, and that gives you B, C, D, A. Alright, so if we talk about a line arrangement, these 4 of these, they're all in different position. Alright, so they're considered to be like 4, they're considered to be the difference, right? But now with the circle arrangement, all of these 4 are considered to be the same. So therefore, for circle arrangement, the final answer to this, it will be 4 factorial, but we need to divide it by 4 of them, which is same. Okay, so for each of the arrangements here, you've got 4 of them. When you're arranging the circle, that's going to be the same, which is 4 factorial divided by 4, and that is equal to 3 factorials. Okay, or you can also use another formula, which is m minus 1 factorial. Okay, because 4 minus 1 is 3 factorial. So I'll talk about this formula in a minute. Okay, so you can just use 4 minus 1 factorial, 4 minus 1 factorial, and that gives you 3 factorials. Okay? Alright, now we'll talk about this one in detail. So this is basically one method to think about why the circle arrangement is 4 factorial divided by 4. Okay? Just because if A, B, C, D were arranged in a straight line, we're just going to move on. If they're arranged in a straight line like this, we just move them all along one position to the right, and then there are 4 positions with different starting letters here. Okay. However, for every one arrangement of this in the circle group, there's only like it's the same. So that's the reason why you need to divide it by 4. Okay, because you should be able to see that for every one arrangement of this group in a circle, there are 4 different arrangements of the same group in the straight line, and that's considered to be one arrangement in the circle. Okay, and then however, with a line arrangement, you've got 4 of them, so therefore you need to divide it by 4. So in this case here, if we have like 6 letters, that will be 6 factorial divided by 6. Okay, because for one arrangement, if you rearrange like in a circle arrangement, then there will be 6 of them in the line arrangement. Okay, so that's one way you can think about it. Alright, so the definition for a circle arrangement is the number of ways of arranging n different objects in a circle. Okay, regarding actually it doesn't matter which are clockwise or anti-clockwise direction. Okay, regarding clockwise and anti-clockwise direction arrangement is different. Okay, and then it can be shown n factorial over n, which is also equals to n minus 1 factorial. Okay, I don't think they mentioned that in the Cambridge textbook, all right, with this formula here, but I was, I highly recommend everybody remember this formula. All right, now just remember this, in the circle arrangement, there is no start or finish. Okay, it's not like a line arrangement. We're going to have a starting point where A is the starting point and B is the second letter, C and D. For the circle arrangement, there is no starting point. You can't say that is the starting point or this is the starting point. There is no starting point. So therefore, what we need to do is we need to just count the arrangements. We need to fix the first object as our starting object. All right, so that's leading us to the second method to dealing with this formula here and y is equal to n factorial over n. Okay, using the second sort of like a method. All right, so basically what happened is with the second method to think about like y for the circle arrangement is n factorial over n is, I want you to think about it this way. There is no starting position. So for example, A, B, C, D, there is no starting position, where is the starting point, right? So all we need to do is we need to fix one place, and then with that particular place you can say that's the fixed place, or that is the fix the place. Fix one position and we call that is the starting position. All right, so that's another method to actually think about y is equal to n factorial over n instead of using the previous method by listing all the 4 different cases or number of cases. The second method is, for example, if we just find this place as the starting place, okay, if we just fix that place to be the starting place, then the other 3 letters, so for example, with that starting place here, we're going to have one letter to be placed, all right? So therefore, with the other 3 letters, all right, where we have 1, 2, and 3, if we fix this one as the starting place, then for the other 3 letters, they can rearrange among themselves, all right? So that gives you 3 different, 3 factorial ways. All right, because there is no first place to fill. All right, so we'll fix that place and rearrange the rest of the other, 3 places, which in this case here, that is just 3 factorials. All right, so that's another way to actually think about it. All right, so this is what about a circle, circle arrangement. Now with circle arrangement, sometimes you also have some restriction question as well. Okay, so you have to be extremely careful when I was dealing with restriction question. Now usually dealing with restriction question is we usually dealing with the restriction first, and then you're dealing with the rest of the other arrangements there. All right, so let's just have a look at some of the examples. All right, example 1. Now we've got 5 boys and 5 girls are to sit around the table. Hand ways can be done without restrictions. So we'll start with the first one. 5 boys and 5 girls. Okay, 5 girls and 5 boys I just sit around the table. Alright, now the question is asked you to find out in how many ways this can be done. First, obviously, without any restrictions. So the boys and girls can sit anywhere they like to sit, okay? And they can sit with any of their friends. There is no restriction here. And in that case, it's pretty easy. If there's no restriction, obviously, for this question, it can be done really, really easy. We're just using our formula, okay? All right, so in total, we've got like 10 people here, all right, 5 boys and 5 girls. There's no restriction. So what we can do is we can fix the first place here, and the remaining 1, 2, 3, 4, 5, 6, 7, 8, 9, remaining 9 students or 9 people there, we can rearrange, within them. So in that case here, that will be just 9 factorial, okay? A really easy one to do. All right, what about the next one when we have some restriction now, okay? What about if boys and girls are alternate? Okay, if the boys and girls there has to be in alternate position, so we have 1 boy, 1 girl, and goes on this fashion here. And how would you do this question in this case? Now, this is going to be an interesting one. Just because we have boys and girls in alternate position, this is also a circle arrangement. Now, for example, if this is a line arrangement and the boys and girls are in alternate position, if it's a line arrangement, in that case, it will be something like this. I'll show you. So it will be boys, girls, boys, girls, boys, girls, and goes on. So that would be like a 5 factorial times by 5 factorial. And we can also times by 2 because the boys and girls can be in an alternate places. You can have the girls to be the starting point or boys to be the starting point. All right. However, if we rearrange, okay, around the circle, there is no starting point. So we have to first fix first person, okay, as the fixing person. Remember this, always fix one person. So for example, if we just fix the boy here, okay, so let's just say if we fix the boy, that boy is fixed, all right, so that we have 1, 2, 3, 4. Now, with remaining 4 boys, the number of arrangements will be just 4 factorials. Okay, when we fix the first boy. Once we finish that, then we can now put girls in. Okay, so we can have 1, 2, 3, 4, 5. We've got 5 places to place the girl. Okay, now within those 5 places, girls can be alternate. Okay, they can rearrange. Like this girl can be sitting here or can be sitting there. So therefore, there will be 5 places for the girl to sit in this position. 4 different girls can be sitting here. So that's 5, 4, 3, 2, 1. All right, so therefore we times by 5 factorials. Now, some people probably are asking, like, why are you not timesing 4 factorials by fixing another girl? There's no need because you have already fixed the boy, okay? So there's no need to fix the girl anymore. And within these 5 girls, they can sit anywhere they like as long as it's actually in between of the boys. So therefore, it's 4 factorial times by 5 factorials. Okay, so that's how we need to do this question here. All right, so it's pretty interesting. Now, question C. For question C, if there are 5 couples and all of them are sitting together. All right, so if there are 5 couples and they're all sitting together, so how do we do that, okay? Now, firstly, we need to think about within those 5 couples, all right? So, for example, if we have 5 couples, let me just draw the circle first. And then we have 5 couples, like these 2 are a couple. Now, they need to be sit together. But remember, within these 5 couples, you've got 2 factorial ways to sit them, right? Because, you can have, the boy and the girl first, or the girl and the boy. So you can have like a cross and circle. So there are 2, okay, different ways to setting like those 5 couples, right? So within each couple, there are 2 different ways. Now we have 5 couples, so therefore we times, there are 5 of them. We'll have 5 of these. So in total, we have 2 to the power 5 ways of ordering these 5 couples, okay? All right, so does that make sense? All right, within these 5 couples, we've got 2 to the power 5 ways. All right, just because we have like 2 times by 2 times by 2, 5 times. All right, so we'll have like 2 to the power 5 orderings of those 5 couples. Now once we actually finish ordering the couples, then we just have like we just need to place the couples around the circle here. Now remember this, it's very similar to the previous one. All we have to do is we fix one couple. All right, and then for the remaining 1, 2, 3, 4 couples, we need to rearrange them, and that's 4 factorials. So therefore, that just becomes 2 to the power 5 times by 4 factorials to finish off this question here. All right, so yeah, it's not a very difficult one to do. I guess like the only difficult part is just this one here, because within each couple, these can be rearranged like in this order, so it can be like A B or B A order here, so that's why you need to times by 2 5 times, and that's 2 to the power 5. All right, let's move on. Question D. All right, now what about this time if all the boys want to sit together and all the girls want to sit together? All right, so if the boys sit together and the girls sit together. Right, now if boys and girls are all sit together, that's actually pretty easy now, because we only have like 2 big group. Right, if you think about this, is big group with 5 boys, and we've got another big groups of 5 girls. They're all sitting together. Now if we just fix the boys, for example, then you only have 1 arrangement for girls. Okay, so there will be just like a 1 times by. The next one then you need to think about is within those 5 boys, how many different arrangements are possible? Well, that's 5 factorial ways to rearrange those boys, and then within the girls, that's 5 factorial ways again to rearrange the girls. So therefore, that just equals to 1 times by 5 factorial times by 5 factorial. Okay, and then of course you can use your calculator to work out the answer there. All right. Okay, so that's question D. Very simple. All right, so the last one. All right, so if 4 couples sit together, so remember we've got like 5 boys and 5 girls, right? If 4 of those couples actually sit together, but however 2 people like A and B do not, okay? So how would you do this one? If 4 couples, now this time 4 couples they were willing to sit together, but the other 2, they don't want to, so they have to be separated by those 4 couples. All right, so person A and person B, they don't want to sit together. All right, so how would you do this one here? Same thing, what we need to do, let's first think about if 4 couples are sitting together, then in that case we'll have like, 2 times by 2 times by 2 times by 2, which is 2 to the power of 4 different ways to ordering those couples, right? And that is 16. Okay, so within those 4 couples, we'll have 16 ways to order them. Okay, that's very important. All right, so once this is actually done, then the next one we need to think about it is how do we, rearrange the other 2, person A and B here. So we've got like, for example, person A are sitting here. So person A is fixed, okay? All right, so person A is fixed, or we fix person A, so therefore that's one way of doing it. All right, and then we are going to place the couples. So I've got 4 of them, so therefore 1, 2, 3, 4. Now, those are where the 4 couples can be sitting, okay? All right, now, within those 4 couples, all right, 1, 2, 3, 4, these 4 couples can be rearranged, of course, right? So think about this. This is couple number 1, that's couple number 2, 3, and 4. Now these 4 couples, this couple number 1 can be sitting here, couple number 4 can be sitting there. So after we fix the first one, then we have remaining of 1, 2, 3, 4 factorial ways to rearrange those 4 couples. So we times by 4 factorial. And then we need to now place the person B. Now think about where the person B can be. You can't place the person B next to person A, so therefore you can't place besides person A. So that gives you only 3 places to place person B. 1, 2, 3. These are the 3 places you can place person B here and there. All right, remember you can't place the person B just next to A because that A and B, they do not want to sit together. All right, so therefore there are 3 different ways to do that. All right, so therefore at the end, it's 1 times by 4 factorial times by 3. Okay, to actually finish this question here. All right, so this is what the arrangement around the circles is about. All right, you're going to see some probability question as well, but this is very similar to the previous question. We just need to find out the total probability when people are sitting actually around the circle, and then if the question gives you some restrictions, then you find the number of arrangements when the restriction is actually applied, and at the end you divide the restriction by the total arrangement, and you get your probability. Okay, that's all. Thanks for watching. Let me know if you have any questions around this topic here. Thank you.